Hello, today we are going to take a look at my recent purchase, and it is DC distribution panel. Here you've got the company, just in case you would be interested. And it is quite interesting model, and I will tell you why. So first we've got an extremely nice and simple manual, so we can go into 32 volts DC. Here you've got the specification. You've got the fuses that are, looks like, included. And this is how it presents. Just take a look. In my 12 volt DC emergency / solar power system, I get the need to have got 24 volt subsystems using DC to DC converter, and I had to create separated fuse blocks for the 24 volt system. And you might get feeling that it is something extremely common that you can purchase everywhere, and that's because in every car you've got some sort of fuse box. This device is extremely special, and I will show you why. So let's try to open it. Let's see how to get access. Absolutely beautiful. And you tell me why this device is different from something that you can purchase extremely cheaply, and it's being used inside vehicle. Let's try to guess. If you spot the difference that here we've got a negative bus bar, then you are 100% correct. On general automotive DC distribution box, you are not going to find the negative bus bar, and that's because your whole body of car, of your vehicle, is carrying negative potential. So if you take a look at your alternator, your wire from alternator do not go into battery, it go into body. If you've got your car battery negative do not go into the DC distribution box, it go directly into whole chassis of the vehicle. And that's the reason why almost all devices like this do not have the negative. You are only going to be fusing and interconnecting the positive, and you have to create yourself some kind of ugly bus bar. And this is absolutely great and absolutely beautiful because you've got a negative bus bar in single device. Absolutely beautiful. Because of that, I deeply believe that this device was intended to be used in like marine applications, maybe on boat or in RV. And that's because those vehicles are mostly made out of fiber or glass, and you are not going to find a negative metal elements that are interconnected and that could be used as a negative. So they are using two-wire system. So let's take a look. This whole package was included in that set. We've got whole set of different car fuses, and we go as little as 5 amp, 15, 20, 10 amp. So it is a really solid selection of the most common value. But because there are generic automotive one, you've got absolutely no problem in purchasing the one that you actually need for the wire that you are going to be protecting. Here you can see we've got labels that can be used, and we've got a nice selection. Let me show you what kind we've got. So as you can see, you've got like a boat, just like I told you, for a marine application, navigation light, DC outlet, absolutely beautiful. I will definitely use it. We've got a lot of different VHF radio, absolutely beautiful for amateur radios. And you can put them here, so you know which fuse corresponding to what application. As you can see, we've got those beautiful LED lights, indicators, and if fuse is going to be blown, it will light up. And in general, they are extremely cleverly connected into legs of that fuse. And if fuse is removed, then you've got the current that is passing through the device and it's going to be lighting up. It is extremely clever design. If you put fuse, then the voltage is going to be 0 because only the voltage that is go through the Ohm law as the current passing the resistance. So in general, it will be so low that the light will never lit up. It is extremely clever and we are going to check it out. For start, let's put our 20 amp fuse. Let me find the 21. Here we've got our 20 and we nicely insert it just like that. Absolutely beautiful. They are also fuses that are reset-able, but I do not think there will be enough room for that. No, definitely not, because they are taller, but they've got a button that you can press. But this is not a problem. They are extremely cheap. It looks absolutely beautiful, but we definitely need to crimp something. I would not just put a wire there. Absolutely not something that I would be doing. So I will show you that on the video. Here we've got our positive, and as you can see, it is more beefy, and that's because it's going to be our main in. Here we've got all the positive terminals. Each of those terminals is nicely fused because the largest fuse is 20 amp, so I will assume that will allow to pass at least 20 amp because I cannot see what is the wiring inside. And I'm sorry, we've got absolutely beautiful information, and we've got 30 amp per circuit and 100 amp as our input. So it is a really decent value. And here you've got all the information. I make terrible mistake, and I'm not sure if I'm not going to need to buy second one because everything fall apart. But looks like no, we do not need to be scared. Those tiny wires are just for a LED indicator, so they will not carry any current. And this is our bus bar. So if that's enough for 30 amp, I think that 30 amp can be okay. How do you feel about that? Here the fuse go. So it's going like this. So it is a very nice design. Yeah, it's go with a nice force, so there will be no problem with the resistance. It is clever design because it is one piece of metal. So yeah, it makes a lot of sense. Let me try to put it back. I was extremely scary because they start flying apart, and from top it was looking scary. But looks like we do not need to be worried. It is clever design. One piece of metal. Here is our bus bar. Here is the negative bus bar. Looks good. And this is our negative bus bar. Looks absolutely beautiful. For the price, I would say it is 100% beautiful design. For the asking price, with all those fuses, I'm going to say it's great. I will be attaching this cigarette lighter adapter. This is not the correct one, we should crimp the Y, but for today, for our test, we will do it like that. So we are going to be nicely going like this. Keep in mind this is not the proper way, I will show you the proper one. And I'm going to be using negative on the negative bus bar. Let's go like this. Absolutely do not pay attention. It's going to be made the professional way. Here I've got my beautiful 24 volt kettle and we are going to be connecting it here. Then we are going to be grabbing my power supply. Our negative go into negative input of bus bar. Our positive goes here, and we can turn on my power supply. It's doing self-test, we are 27 volt, and our kettle should be working. And yes, it is. As you can see, the kettle is working, and the light indicator is not being lit up, and that's because our fuse is not burned and the resistance is creating voltage across that fuse and it is extremely small. So let me pull it out and we should see our indicator being lit up and you know the fuse is open. And you might ask yourself why those are not being lit up, and that's because it require current flowing through your device. So when I'm going to disconnect our kettle and remove the load, it should go out. And as we predicted, we've got exactly the same operation. We replace our fuse, and as you can see, the current is flowing, lid is extinguished. Absolutely beautiful, lovely design. I enjoy it very much. Let's see how does it present after adding our cover. And it looks absolutely... I leave it running. The water is already boiling. As you can see, it nicely bubbling up. Is it warm? Absolutely not. I can even touch the fuse. Nothing wrong is happening. But we are only at 11 amp. So to the 30 amp max limit, we've got a lot of headroom, but I found this and it is set of different wire lag terminal, and this is what I'm going to be using. It will be nicely fitting here and create a secure connection. I'm going to be nicely removing it like this. Here it go like that. We are nicely inserting it like this. And we are going to make absolutely beautiful secure connection. As you can see, we've got my beautiful DC distribution block already in place. We've got it connected to 24 volt rails. Those are those beefy cables. And I've got fuse in place toward my device, and we are going to take a look how the overcurrent protection is going to be working. And as you can see, the LED indicator is not lighting, and I will create a short circuit and we should observe how nicely it's going to be blowing, and indicate our fault. So let's do it right now. And short circuit in 3, 2, 1, go. As you can see, we've got a clear indication that the fuse was blown, and we can remove it. And as you can see, it nicely burned, and I can replace it with the correct value. And as you can see, now the indicator has go off. So as you can see, it's working absolutely beautiful as intended. So as you were able to see, it looks absolutely beautiful after being mounted on my wall, and it's working great. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.